Hey friends, I'm going to take you through a couple of examples in figuring out and predicting products for acid-base reactions. First thing, let's take a look at what the acid-base reaction looks like. This is the neutralization reaction, and so we'll do more stuff later on with titrations and so forth, but you have to be able to identify at this point. What you'll see is an H. This is our acid, and we know that from our naming, our nomenclature. And then you'll see an OH here, and that is our base. When you see a hydroxide, you'll know that's a very common base. That's not the only base on the planet, but in Chemistry 1, that's a really common base. What we'll see then is we'll see a nonmetal that forms with the acid or an anion, like a polyatomic ion, and we'll see a metal that forms with the hydroxide. When they join together, notice this H is going to combine with this OH, and instead of writing HOH, we write it as water, H2O. And then we end up getting a salt, which is an ionic compound, because we take the metal that's with our hydroxide and the nonmetal that is with our hydrogen, and that's what forms our ionic compound. So let me show you a couple of examples here. So let's go through here and predict the products. And I'm going to write on here for you. So let's take a look at the first one. We have sulfuric acid plus aluminum hydroxide. So here's our H and our OH. So let's make our water out of that. And you could write water first or second. It doesn't matter which order you write the products in, as long as they're both products. It doesn't matter. So then we look back and we see aluminum and we see sulfate. And so we want to put those together as our salt. But remember, don't take any baggage over with you. Instead, you just write aluminum and sulfate. And then we want to check the charges. So remember, sulfate is a 2- charge, and it's a polyatomic, so we keep it together. Aluminum is a 3+ charge. So we'll crisscross, and we'll get Al2, SO4, 3. Now we need to balance. So when we go back to balance, we want to take a look at the first thing is you want to balance your metal and your nonmetal. So let's look, we have one aluminum on this side and we have two aluminums on the product side. So let's put a 2 in front of aluminum hydroxide here. And then on the reactant side, we have one SO4 and we have 3 SO4. So we want to look at it as an entire SO4. And so we put a 3 here. What I want you to be careful with here is look at your polyatomic as a whole. Like this SO4, take this as an SO4. Don't try to break it down into sulfur and oxygen because you'll end up counting a whole lot of oxygens and get really confused. Now the final step is we're going to save our hydrogens and oxygens for last. So we have hydrogen in 2 places. We have 3 times 2 hydrogens here, and then 2 times 3, because so we have 6 hydrogens here. So total we have 12 hydrogens, and here's our oxygen. So we have 2 times 3, 6 oxygens. So to have 12 hydrogens and 6 oxygens, if we put a 6 in front of our water, we're good to go. So this equation is now balanced. Let's look at the second one here. We have an acid because of that H. We have a base because of the OH. We put those together and we have H2O. And then we're going to take our calcium, which is our cation, our chlorine, which is our anion. And remember, you always write the metal first. So we have CaCl. Ca is a 2+ charge. Cl is a -1 charge. So we have CaCl2. Let's balance our calcium and our chlorine first. So on this side, on the reactant side, we have one calcium on the product side. We have 2 chlorines on the product side. Let's get 2 chlorines on the reactant side. So now finally, we'll balance our hydrogens and oxygens. So we have 2 hydrogens here in the hydrochloric acid, and we have 2 hydrogens in our hydroxide. So therefore, we have a total of 4 hydrogens, and right here we have 2 oxygens. So 4 hydrogens and 2 oxygens, we simply put a 2 in front of our water. Finally, let's look at this last one. We have phosphoric acid and potassium hydroxide. So let's take our H and our OH again. Again, our H indicates our acid, and the ending as an OH or a hydroxide is a base. So we'll make our water, and then we take what's left over. We have potassium and we have phosphate. So let's add, and we put potassium first because it's a metal, and we put our phosphate. And our phosphate is a polyatomic with a 3- charge, and potassium is a 1+. So therefore we have K3PO4. So finally, we're going to, again, round our metal and non-metal first. So our potassium here, we have 3 potassiums in our product. Let's have 3 potassiums in our reactant. Then we have 1 PO4 and 1 PO4. So we're fine there. Now let's do our hydrogens and oxygens last. So we have 3 hydrogens, and looking at this 3 as a coefficient, 3 more hydrogens. So we have 6 hydrogens total, and then we have 3 and an oxygen. So we have 3 oxygens. 6 hydrogens and 3 oxygens. Therefore, we're going to put a 3 in front of our H2O. So keep it simple. Like, just know the fact with an acid-base reaction, you have to have an acid and a base. I know that sounds silly to think about because you're like, oh, there are acid-base reactions. But some reactions have an acid with something else. Some reactions have a base with something else. So you have to have both the acid and the base in order to get your water and your salt. All right. Take care, guys. I'll see you later.